All right, so guess I picked a bad time because nobody is here. That's okay, I'm still going to go through. So I'm going over the power of a quotient rule. I already have a video on some of these other rules of exponents, and I thought that I would do some the power of a quotient rule in detail so you have practice with it and you can see more examples. So we have several rules when dealing with exponents or properties of exponents. There's the rule when you multiply exponential expressions, you add the exponents. When you divide them, you subtract. The power rule is when you have an exponent on top of another exponent, or a power with an exponent, you multiply those. And power product, basically you distribute the exponents, and power quotient is the same thing. You can distribute exponents across a fraction. So it goes to the top and the bottom of a fraction. Then there's also rules for negative exponents where you take the reciprocal to make the exponent positive, and then the zero exponent where anything to a zero exponent is 1. So I'm focusing on power of a quotient where we have fractions with exponents. So simplify. This is just literally practicing the power of a quotient rule. So step 1 is to use power of a quotient rule. And we'd be doing that on both of these. So I'm going to just write that down. Now, this is good for your notes to write it down as well so that you have that, so you know what rule you used. And you basically distribute the exponent on the outside of parentheses to everything on the inside. So for the first example, that would be 1 to the 8 over t to the 8. For the second example, that would give us w to the 7 over z to the 7. Now on the right, they're variables. There's nothing we can do. So we're just literally distributing that exponent. On the left, however, I can simplify 1 to the 8th. So 1 to any power is equal to 1. So it doesn't matter what that exponent is. If I use n, whatever, it's equal to 1. I can actually make that a box if that 1 to a box is equal to 1. So that we would write this as 1 over t to the 8th. Now here we've got some negatives, and for the first example, it's negative 2 over x. So I find it helpful to write that as that if there's a negative and then a number, to kind of put the number with the negative. So I'm going to just put that negative up with the 2. It just makes things a little bit easier to work with. So I'm just rearranging where the negative is. And our first step is to use the power of a quotient rule. Which I'm going to just abbreviate PQR for brevity. And so we're going to take, and I'm including the negative here, the negative 4, or negative 2 is getting an exponent of 4. And then x is getting an exponent of 4. Now, negative 2 to the 4th power, that's going to give you a positive answer out because a negative to an even exponent is always going to be positive. So we're going to get a positive, and then 2 to the 4th is 16. So this gives us a positive 16 over x to the 4th. Now on the right, I don't have a number to put that negative with. So I'm going to rewrite it with a negative 1 so that we do have a number there. So I could put the negative 1 in the denominator or the numerator. I just usually always do the numerator. So I'm going to just put a negative 1 there, and then we've got r over s, and that's to the 3rd power. So we're going to use our power of a quotient rule to distribute that exponent. So we get negative 1r to the third over s to the third. I can use the power of a power rule to then distribute that 3 further. So that would be -1 to the third power, r to the third power, and then s to the third power. So that 3 gets distributed. So that's an additional rule. Then we can do -1 to the third power. So a negative to an odd power is going to give us a negative out. So, and then 1 to any power is 1. So we're going to get a -1 r cubed over s cubed. Or you can write that as -r cubed over s cubed. Make my 3 look like a better 3 there. Make my s. And now that looks like a 5. S. There we go. Okay, we're getting a little more complicated here. So always start with the power of a quotient rule. So it's going to get 4 to the 5th power. And then rs to the 4th gets the 5th power. So that exponent just goes to the top, and then it goes to the bottom. Then we'll use the power of a power rule. So let me actually, for these abbreviations, let me just create abbreviations here to make it easier for you. So this is PQR, power of power of a product. Oh yeah, that works. I keep saying power of power, but it's power of a product rule. Call this power rule. And okay, so I'm going to go back to my other example. I wrote power of a power and meant power of a product, so I should fix that. There we go. Too many P's. Okay, so I need to use the power of a product rule in the denominator. Power of a product rule. So the numerator is staying the same. And I'm going to just change colors here so it doesn't get too confusing with all the fractions. So the r gets the 5th power, and then s to the 4th gets the 5th power. Now I need to do something with the s to the 4th to the 5th, so that's the power rule, which I'm abbreviation is PR. So we have 4 to the 5th over r to the 5th, and then you multiply those exponents. 4 times 5 is 20. And now we need to simplify. So you can do 4 to the 5th power on your calculator. So I certainly don't have that memorized. That's 1024. And then we have r to the 5th, s to the 20. And that's our final answer. So now on the right, first step is to use your power of a quotient rule. So P, Q, R. So the 2 in front is not going to have anything to do with it. So it's just 2 times. And then we have 3P to the 5th over Q third to the 5th. So I'm just taking that exponent of 5 on the outside and applying it to the things on the inside. Now let's use the power of a product rule on the top to distribute that 5. So I want to kind of do these in the same steps. So we have 2 times 3 to the 5th times P to the 5th all over Q to the 3rd to the 5th. So next will be the power rule. So you can see that we're doing the same steps over and over again. So I'm going to do the power rule in the denominator, where I have the q to the third to the fifth. I need to multiply those exponents. So I have 2 times 3 to the fifth, p to the fifth over, and then I multiply the exponents. 3 times 5 is 15. So now I want to simplify 2 times 3 to the fifth. So 2 times 3 to the fifth, because I'm kind of running out of room here. 3 to the fifth on my calculator is 243. So this is 2 times 243, which gives me 486. So the number portion is going to be 486. Then p to the fifth over q to the 15. Okay, now we're getting a little more complicated. Technically, the example on the left isn't a power of a quotient rule, but it does involve fractions, so I thought it would be a good one to do. And then the example on the right is power of a quotient rule. So on the left here, so we don't actually have a quotient to do a power, so we can go next to the power of a product rule. So we'll follow the same order. And the things that we're doing the power in a product rule is going to be the negative 2w to the fourth to the fifth, because that's the thing where you've got things multiplied inside the parentheses. So my w cubed squared, I'm not going to do anything with that just yet. Now that negative 2 is going to have an exponent of 5. And then the w to the fourth gets an exponent of 5. And then the denominator here, w to the fourth, gets an exponent of 2. Next is the power rule, where you multiply your exponents if you have an exponent on top of an exponent. So top of the fraction, I have w cubed squared, so you multiply those. 3 times 2 is 6, so that's w to the sixth. Now I've got this negative 2 to the fifth, so I'm going to just put that in front, because we usually put the numbers in front. Let me actually rewrite that so it looks a little nicer. W to the sixth, and then w to the fourth to the fifth. 4 times 5 is 20, so that's going to be w to the 20. And then w, 4 times 2 is 8. So I get w to the 8 in the denominator. Now I have multiplication of my, on the top here of my exponents, or things with exponents. So we're using the multiplication of exponential expressions. So let's say multiplication rule, and then we can call it the division rule here. So multiplication rule, so I'm going to do the top. So the negative 2 to the fifth is staying the same. And then I add my exponents when you're multiplying them. So 6 plus 20 is 26. And then it's over w to the eighth. I'm running out of room here. I didn't really think ahead, so I'm going to just duplicate this slide and then do the second example on the next slide. So we'll just do that. I'm going to get my thing back up. Okay, so let me just, we're going to continue. So done the multiplication rule. Now we need to use the division rule because I have division here. So I am dividing the exponents. I've got a 26 over an 8 there with my exponents. So the negative 2 to the 5th is staying where it is, and then you subtract exponents, 26 minus 8. So I'm going to do that on my calculator. That gives me 18. So I get W to the 18. And then we're going to simplify that. Negative 2 to the 5th power. So a negative to an odd power is going to give me a negative. 2 to the 5th is 32. So I get negative 32 W to the 18. And that is the final answer. Okay, so we've already done the first one, so I'll just cross that out. Second one here, we're going to have to use this power of a quotient rule, although sometimes it's easier to simplify inside beforehand. So actually, I could not even do the power of a quotient rule, and I could simplify on the inside first because I have x's and y's and I have z's. So you can get the same answer either way, and it's about okay, what makes things easier? You know, if you follow the rules that I've been doing, the steps where power of quotient rule first, power of power, then your power rule, that will do it one way. But in here, it would actually be smart for us to use the division rule first to simplify, and then go from there. So I'm going to start with the division rule. And so what that means is on the x's, I'm going to be subtracting the exponents. The exponent of x in the denominator here has a 1, so it's 3 minus 1. So I'm going to get an x squared. On the y's, I'm going to be subtracting 5 minus 2 is 3, so that's going to be y to the 3rd. Then I have a z, because there's no z in the bottom. And then in the denominator, I have a 5. And we still have our exponent of 2 out there, but I've just at least made the inside a little simpler. Now I'm going to use that power of a quotient rule. So I will distribute my exponents. So my x squared, the x squared y cubed z has an exponent of 2. And then 5 gets an exponent of 2. Next is the power of a product rule, where you distribute these exponents on the top here. So x squared has a 2 from the outside 2. Y cubed has a 2 from the outside 2. And then we get z squared. And then all over 5 squared. Now, when you get really good at this, you can kind of do all of these in your head and you don't have to write so many steps, but it's good to do it step by step. So now I'm going to use the power rule because I have exponents on top of exponents. So you multiply the exponents. So I have x squared squared, so 2 times 2 is 4, so that's x to the 4th. Y cubed squared, 3 times 2 is 6, so I'm going to get y to the 6th. And then z squared, and then 5 squared. And now the last step is to simplify. We can't really do anything with our exponents on the variables. Keep wanting to write a number other than 2 on the z. But the denominator, I can square 5. 5 squared is 25. So that leaves me x to the 4th, y to the 6th, z squared over 25. Okay, now here's another one that isn't strictly the power of a quotient rule, but is on a fraction. So I wanted to kind of go over the best way to do this. So we can skip the power of a quotient rule and go to power of a product rule in this case. So we don't have a quotient, and we don't have any division or anything on the insides of the parentheses to simplify. So we're going to use the power of a product rule first. So we're not doing anything on the 6, well, no, we are doing something on the 6s. The 6 is getting the square, and then s cubed is getting the square. And then our next set of parentheses, we have an s to the 4th, getting that 2, and then a t to the 5th, getting that 2. And then the denominator, I'm also distributing that 2, so I have a w getting the 2. I'm getting an s to the 4th, getting a 2. T squared getting a 2. So I'm distributing this 2 to basically, I have a lot of 2's going on, but everything is getting a 2. It's a mess of parentheses, so, or arrows. Now we want to use the power rule to simplify all those exponents on top of exponents. So I have 6 squared. Then s 3 times 2 is 6, so that's s to the 6th. Then 4 times 2 is 8, so we get s to the 8. And then on the t, 5 times 2 is 10, t to the 10. In the denominator, w squared. Then s, 4 times 2 is 8, so s to the 8. And then on the t, 2 times 2 is 4, so t to the 4th. Now on top, I have 2 things with s's, so I can use the multiplication rule to combine those, which means you add the exponents. So we've got 6 squared, and then when I add 6 plus 8, that's 14. And then t to the 10 is the same. Denominator is unchanged. Now I have this fraction, and to simplify it, because we have the same variables on the top and the bottom, we're going to use the division rule where you subtract the exponents. So 6 squared is staying there. Then on the s's, we have 14 minus 8. So that brings us to 6, s to the 6th. Then t, we have 10 minus 4, which is 6. And then we still have our w squared in the denominator because that hasn't done any changed or anything. And now the last step is to do 6 squared, which is 36. So we get 36 s to the 6th, t to the 6th over w squared. And that is your final answer.